Welcome to the InnoGuide podcast, where we share the works of authors and mentors to guide innovation. I'm your host, Bob Bouthillier. This podcast, my website, and my newsletter are focused on helping you discover the secrets of innovation in the age of AI. Since I don't rely on paid ads, I want to thank customers who bring me onto their programs as a technical product accelerator to work alongside their teams to help them develop products smarter and faster without adding risk, while bringing human-centered AI skills into their organization. You can learn more at innoguide.net. In this episode, number 107, we'll be sharing The AI Bill Nobody Can Explain by yours truly, Robert Bouthillier. This book started with a rejection letter. I applied for a role at Alpha.School, a company using AI-driven education to reach K-12 students at roughly $10,000 per student per year, with an ambition to serve 1 billion students over 10 years. I didn't get the job, but their approach stayed with me, and I kept arriving at a different conclusion than they seemed to have reached. The better AI model is not enough to reach 1 billion students at $10,000 a head. The economics have to change by orders of magnitude. Not long after that, a client gave me a concrete vision of the same problem. The client ran an engineering staffing business with 150,000 resumes. Processing each new role against the full database through a large language model is what he requested that I do. And after a short investigation and a test, I realized it would cost about $2,400 per query for a new candidate. So I did some investigation and then changed the architecture. I pre-sorted the resumes into a structured database in advance, so the model only reasoned over a short list of at most 200 candidates. So how did this change the cost? It dropped to about $3. That was 800 times cheaper, more accurate, and more predictable. That wasn't a tuning tweak. It was a design decision, and it pointed toward a founding principle. When a task is repeatable and its logic can be made deterministic, build a deterministic program rather than routing it through a model every time. That question, how often is the model simply the wrong tool for the shape of the problem, is the seed of this book. So let's get started. What happens when the meter arrives after a machine already starts running? Here's a story about a company that built its entire business around measuring things and still got surprised by a bill. In May 2026, reports began circulating that Uber had burned through its entire annual AI budget in just 4 months. Not a small team's discretionary fund. The whole year's allocation, gone by April, just like that. The irony is almost too neat. Uber's core business is metering. Every ride has a route, a price, a driver payout. The whole system works because usage is tracked in near real time. And yet, even Uber got blindsided by AI costs it could not see coming fast enough. Reuters confirmed the broader pattern. Companies are being caught off guard by the shift from flat-rate software subscriptions to usage-based AI pricing, where costs are driven by tokens, the units of work in AI system processes. The Wall Street Journal reported that companies like Priceline, Qualcomm, and Bristol-Myers Squibb are now borrowing tools from cloud computing, monitoring dashboards, spending caps, chargeback systems, just to bring basic discipline to AI token spend. For the past few years, the dominant question was simply whether AI could do the work. The answer became yes faster than anyone expected. But once it did, a quieter second question arrived behind it. What happens when it works? I illustrated this with the resume matching problem. Handled as pure AI reasoning, it cost $2,400 in tokens for each new role being assessed. But reframed as a deterministic pre-sort, the cost dropped to about $3. The real risk was never just the cost. It was a kind of laziness AI quietly teaches us. The temptation to hand an entire problem to a model and skip the engineering discipline that would have made the answer more reliable and repeatable. That distinction matters most, exactly where AI is being adopted the fastest. In medical triage, legal research, or financial guidance, if the same input can produce a different answer depending on the day, that's not only a cost problem, it's a correctness problem wearing a cost problem's clothes. Traditional software costs have a familiar shape: seats, licenses, storage tiers. But AI spend is behavioral. Two employees with identical licenses can create wildly different costs, depending on prompt length, model selected, and how many times a workflow loops before it stops. In the old world, the budget was attached to access, but in the AI world, it's attached to behavior. AI cost problems almost always begin as AI success stories. But the trouble starts when people like the tool, and the meter arrives once the machine is already running. For decades, software pricing worked like a simple equation. Count the people who need access, multiply by the per-seat cost, and you know the annual bill. 20 people, 20 seats. Predictable, understandable. The entire foundation of how software budgets got built. Then AI arrived and broke that model completely. The real cost driver was no longer the seat. It was behavior. This became impossible to ignore in 2026 when GitHub announced that Copilot would move toward usage-based billing. Users on monthly Pro plans would migrate to a system where heavier AI usage consumed credits tied to model usage, token consumption, and premium features. It wasn't a fringe product making a quiet change. It was one of the most visible AI coding tools in the world, signaling something larger about how AI economics actually work. Put two developers in identical roles using the same AI coding tool, and the org chart says they're interchangeable. One might use autocomplete and occasional chat. Another might run coding agents for hours, feed large sections of the repository into the model out of habit, and reach for the most expensive available model at every step. The role is the same, the program is the same, but the cost is not. A seat says someone is allowed to use a tool, but tokens reveal how the tool is actually being used. I learned this firsthand on a PC board design platform used in a previous role. For years, the pricing was genuinely predictable, a clean seat-based number. However, then the vendor said the team was consuming more cloud resources than the current tier allowed, so the cost per seat was going up. The seat count hadn't changed. The team hadn't grown. But back-end consumption had crept upward, invisibly, until the vendor repriced around it. Even predictable seat pricing was quietly behavior-linked underneath. Reuters reported that even as token prices fall, companies are finding AI costs harder to control. Cheaper capability invites more usage. Better models invite bigger tasks. Longer context windows invite larger inputs. The company doesn't simply buy the same amount of AI at a lower price. It uses more AI more often. This resembles what happened with cloud computing. But AI adds a twist. Cloud costs were tied to systems. AI costs, though, are tied to human behavior, product behavior, and workflow behavior all at once. A seat is a permission record. A token is a trace of work. And these are questions seats simply can't answer. Which workflow created the spend? Was the model appropriate for the task? When companies manage only seats, they see access. When they manage workloads, they see economics. And that distinction is where AI budgets either hold together or quietly fall apart. In April 2026, Business Insider reported something that looked outrageous on the surface. A 4-person startup called Swan AI had spent more than $113,000 on Anthropic in a single month. The CEO, Amos Bar-Joseph, wasn't embarrassed. He was proud of it. He connected the spending directly to pipeline growth, closed deals, and expanded support capacity. The company was aiming for high revenue per employee and viewed AI spend as leverage, not waste. Most stories about AI are cautionary tales. The bill exploded. The tokens ran wild. The CFO demanded an explanation nobody had ready. But told alone, those stories teach the wrong lesson. A $113,000 monthly AI bill could be irresponsible waste, but it could just as easily be a rational substitute for several full-time hires or an accelerated product cycle. The number alone doesn't tell you which story is true. A large AI bill can mean almost anything. Carelessness or scaling, premium models wasted on repetitive work, or agents looping productively in the background. It means nothing useful until the spend is connected to outcomes. The important question was never, was $113,000 too much for a month? The important question is what the $113,000 produced. Most companies aren't ready to answer this, and the reason is simple. In the demo phase, nobody builds the meter. They build the thing that proves the idea, which is usually the right priority. A founder is trying to show investors the product works. A product manager is trying to prove customers want a feature. During those early phases, the only question anyone is really asking is capability. So the economic plumbing gets postponed. But successful experiments create a trap. The better the demo works, the faster people start using it. By the time the bill matters, the company may be trying to bolt controls onto a workflow that already became operational without anyone deciding it needed one. I ran into this with my own podcast retrieval system. A RAG built over the transcripts from this show at 35 episodes worked beautifully. But by 70 episodes, it had gotten worse. And by 100, it was genuinely bad, unable to reliably list every title and author in the database, even though every transcript opens with exactly that information. Adding more good data was making the system stupider and less capable. What fixed it was unglamorous. Roughly 50 prompts representing the kinds of questions I actually needed answered, checked against every new episode before trusting the result. My demo worked at 35 episodes, but nobody had built the meter, including me, because there was no reason to do so yet. 2 AI workflows that each cost $10,000 a month illustrate the broader problem. One helps close $500,000 in new contract value. The other generates internal summaries nobody reads. The cost is identical. The business meaning could not be more different. Blend those two into a single monthly line item, and that's exactly where organizations get into trouble. Not because of the spend itself, but because of the absence of meaning attached to it. When measurement never arrives, experimentation quietly becomes unmanaged infrastructure. Finance gets surprised, and the response is usually blunt. Access gets limited. Premium models get blocked. Usage caps appear overnight. But blunt restriction can destroy useful learning just as easily, punishing high-value use cases that were never separated from the low-value ones sitting next to them on the same bill. Cognition CEO Scott Wu recently warned that some companies treat raw token consumption as a measure of productivity, when deliverables and outcomes are what really matter. The goal was never to maximize tokens, and it isn't to minimize them either. The goal is to maximize useful work per appropriate token, and that requires an actual model of value, not just a bill. That discipline begins the minute the demo works. So just when did agents start spending our money for us? In the early days of generative AI, the cost model was simple. You typed a prompt, the model answered, and a small bill was generated somewhere. One question, one answer, one transaction. You could see the whole thing. Then, agentic AI broke that model entirely. An agent doesn't just answer. It plans, reads files, calls tools, inspects results, updates code, runs tests, reviews errors, tries again and again. And from your perspective, the instruction looks simple. Fix this bug. Research this market. But underneath it, the system may run through dozens of steps you never see, and every one of those decisions consumes tokens, compute, tool calls, and time. A 2026 research paper examined exactly this problem and found something striking. Agentic coding tasks can consume around 1,000 times more tokens than ordinary code chat. Repeated runs on the identical task could vary as much as 30 times in total token usage. And here's the part that challenges everything we assume about automation. Higher token usage didn't reliably produce better accuracy. Accuracy often peaked at an intermediate cost and then flattened out. So autonomous doesn't automatically mean efficient. There's also a counterintuitive finding about where the cost actually lives. Most people picture AI cost as the cost of generating the answer. But in agentic workflows, input tokens, not output tokens, often dominate the bill. A human developer learns a code base once and carries that understanding forward mentally. An agent, though, may reprocess large amounts of the same context every single time. The expensive part often isn't the final answer. It's the agent's memory of how it got there. I ran into this unpredictability on 2 real projects. The first was a weekend build around a patent I had for an advertising concept called Gratitude, where a diner records a 15-second restaurant endorsement, the owner of the restaurant sponsors it for $1, and a viewer watching it later gets paywall access on the New York Times or another site. I planned the architecture carefully, broke the work into 2 sessions of stepwise instructions, 17 steps, then 21, and I built the whole thing in about 20 hours using Replit. What struck me wasn't the total cost, which was about $45. It was that I had no way to predict it as I went along. The base subscription turned out to be nothing more than a guess about what a typical user might do. A fixed subscription price is a guess, not a ceiling. I call this failure mode agentic theater. Workflows that look impressive because they're active without being economically disciplined. Heavy token consumption gets mistaken for serious AI adoption, when activity was never the same thing as value. Companies already learned this lesson from meetings and status decks that produced plenty of artifacts and comparatively little outcome. Agents just generate the same illusion faster. The better path is to instrument agentic work from the start. Task labels, project attribution, model visibility, tool call logging, retry counts, cost thresholds, and clear stop conditions. Because once agents start spending money for you, question stops being who asked. It becomes what happened after they asked. Here's something else that I learned. The right model at the wrong time is still waste. In the spring of 2026, a new term started appearing in business publications like the Wall Street Journal. Model maxing. It was a deliberate correction to what had come before, a period called token maxing, where companies encouraged heavy AI usage with little regard for cost. But model maxing meant something different. It meant matching the model to the task, choosing based on complexity, cost, and routing strategy, rather than simply reaching for the most powerful option available. It was a necessary correction, but it was also incomplete. Here's the part most people missed. Choosing a cheaper model is not actually the first decision. Sometimes the right answer is no model at all, a cache, a database lookup, or a deterministic process that runs reliably without touching a language model every time. Let me make this concrete with a warehouse analogy. Imagine a company that ships every pallet of bottled water overnight. Some shipments are genuinely urgent, but most can go by ground at a fraction of the cost, and the consumer still receives exactly what they ordered. A frontier model is overnight shipping, worth it when the situation deserves it, but a source of quiet, compounding waste the moment every task becomes an overnight shipment by default. A customer asking for order status needs a database lookup, not a language model. A password reset needs an identity workflow. A document that needs to land in a known format needs a template, not a premium reasoning engine. The fact that an LLM can technically do something doesn't mean it should. The first time a team uses a model to format a document, it's a reasonable experiment. The 1,000th time, it's a costly. I learned this firsthand building my podcast retrieval system that worked well at small scale and quietly degraded as the transcript library grew. The fix was not a better model. It was adding a deterministic indexing layer underneath it. Retrieval got both cheaper and more accurate once the repetitive work was handled structurally and the model was freed for synthesis and judgment. Braintrust made a similar point in its 2026 review of LLM routing platforms. Routing can reduce spend when cheaper models handle requests that never needed a frontier model. But the savings only counts once quality costs are included. A weaker answer that triggers retries or requires human cleanup erases the apparent token savings entirely. None of this gets solved by asking people to make better choices. Under deadline pressure, engineers reach for the safest looking option, and that safest looking option is almost always the most expensive one. That's not laziness. It's how anyone behaves when guessing wrong carries a visible penalty and overpaying does not. The pricing gap makes this consequential. Across providers, the difference between cheapest and most capable models commonly spans 100x to 1000x on a single pricing sheet. Routing does not make premium models less important. It makes them more appropriately important. A model reserved for tasks that actually need it is a strategic resource. And that distinction is the entire difference between using AI and operating it. Now let's look at what happens when a prompt hides a chain reaction. In June 2026, Business Insider reported that OpenAI had set up a war room, not because of a security breach and not because of a product failure, but because users of Codex, OpenAI's coding assistant, were burning through their usage limits faster than anyone expected. But that wasn't the interesting part. The real problem was hidden. Internal Codex features, auto reviews, subagents, background inspection, were running more aggressively than intended. The system was reviewing code, launching subagents, inspecting files, testing changes, retrying failed steps, and summarizing results. All of that consumed metered compute, and users hit their weekly limits faster than expected, causing OpenAI to need to reset caps and improve monitoring. A developer might think, I asked Codex to help with this task. Meanwhile, the system was doing dozens of things the developer wasn't aware of. That gap between perceived work and build work is exactly where companies get surprised. OpenAI's own 2026 research described a shift from chat-based AI toward agentic AI, where tools take action on behalf of users. Active Codex usage grew more than fivefold in the first half of 2026. More than 10% of users were managing 3 or more concurrent agents each week, many assigning tasks estimated to require over 8 hours for an experienced human to complete. That changes the meaning of one request. A coding agent asked to fix a bug may inspect the repository, write a patch, run tests, review the result, and explain what changed. That is delegated execution, a slice of work that would otherwise belong to a developer, a tester, or a reviewer. So let's be careful here. Hidden AI labor is not automatically waste. The problem is hidden labor without attribution, limits, feedback, or visibility. Consider a software firm with several developers using AI coding tools across a client project. At month's end, the firm sees a larger AI bill. The useful question is not just why the bill went up. It is which client, project, and task caused the usage, whether the cost should be billed or absorbed, and whether the work justified the spend. A project that looks profitable on labor hours alone may be less profitable once AI usage is added. I want to make a distinction between the 3 kinds of hidden labor. Some is essential, safety checks, source retrieval, audit logging. Some is valuable but optional, a deeper search worth running for high-risk decisions but unnecessary for routine formatting. And some is simply accidental, retries caused by poor instructions, large context windows used because no index exists, and background tasks running because nobody noticed a configuration setting. A good AI operating system should help a team tell these apart, protect the essential labor, measure the optional labor, and redesign the accidental labor. Here's a test worth applying to any hidden AI process before scaling it. Not is this expensive, but if I ask the same hard question again next month, would I trust the answer without checking? If yes, the hidden labor has earned its invisibility. If not, that gap is worth closing before the workflow gets bigger. So while some companies have tried to rein in AI costs, others have been trying to increase the use of AI programs at one time and rein them in at another. Here's an example of this. In February 2026, Accenture made a bold move. The company told its senior staff that consistent AI usage would factor directly into promotion decisions. Weekly logins to AI tools were being tracked for associate directors and senior managers. Regular adoption became a real condition of advancement. However, 4 months later, the same company was telling staff to rein that usage back in. Accenture is as sophisticated a technology consultancy as exists anywhere. The lesson isn't that the company made an obvious mistake. It's that a policy built entirely around encouraging usage has no matching policy for attributing it. Logins were tracked, but the shape of the work behind those logins was not. When a company can't tell an associate director closing a client engagement with AI-assisted analysis from an employee running expensive models on formatting busy work, rewarding usage and restricting usage end up looking like the same blunt instrument applied to behavior nobody had actually measured. That's not a story about Accenture being careless, but it's a story about what happens when adoption outruns attribution. And if that's true for one of the most AI-literate consultancies in the world, it's certainly true for law firms, software shops, and agencies. This is where AI spend stops being just an IT budget problem and becomes a billing problem. When AI becomes part of the client delivery, the economics change. A law firm using AI to review contracts has a cost. a software firm using coding agents to build a client's application as a cost. The question was never whether to show the client every token. It's whether the firm itself even knows where the cost belongs. A company can't choose a billing model for costs it doesn't see. Consider a $40,000 fixed-fee software sprint, planned around developer count, expected hours, and scope. During the sprint, developers use a mix of coding agents, Claude Code, Codex, Cursor, GitHub Copilot, that write tests, review code, and generate patches. The team moves faster, which sounds good. But if the sprint quietly generated $1,000, $3,000, or $10,000 in AI tool costs that were never built into the project economics, that cost comes straight out of margin. Without attribution, nobody really knows which story is true. The same problem appears inside software products. Many companies are building AI features into platforms for which they charge customers a fixed monthly fee. Revenue is fixed. The underlying cost is variable. One customer might use the AI feature lightly. Another might trigger long context retrieval and premium model calls constantly, quietly consuming the margin of their entire plan, or more. A business can discover that its most enthusiastic customers are also its least profitable ones, and never see it coming. But there's also a design dimension. Remember the resume matching system built for the temporary engineering staffing client? It was a naive approach, asking the model to reason across an entire 150,000 resume database would have made each search absurdly expensive. But once the problem was redesigned around deterministic pre-filtering, the cost per search fell by roughly 3 orders of magnitude. The opportunity was never just to bill AI costs after they happen, but rather to design the workflow so the costs make sense in the first place. The solution was particularly unglamorous and old school, if you will. To get started, you really just need a few broad categories. Billable work tracked by client or project, and non-billable work tracked by department. The first version doesn't have to be perfect. It just needs to be better than one blended bill. Because once categories exist, patterns emerge. Maybe one client drives most of the coding agent usage. Maybe one automation is quietly looping. The Wall Street Journal reported that companies are already borrowing from FinOps practices for exactly this reason, using showback and chargeback to connect AI usage to business responsibility. Attribution has to come before billing. Billing is a policy choice, but attribution is an operating requirement. Tracking whether people used AI was never the same as tracking what that use actually cost or produced. A firm that mistakes one for the other finds out the difference only when the bill or the backlash arrives. So what exactly is being borrowed from FinOps, showback and chargeback that we just discussed? Before cloud computing, infrastructure spending was slow, but it was visible. Someone had to approve the servers, justify the need, and sign the budget. Then cloud arrived, and all of that changed. Teams could spin up resources in minutes, but bills could grow in places nobody expected. A server left running, a test environment that quietly became permanent, storage accumulating without anyone noticing. The problem wasn't bad intent. It was elastic access without enough visibility into what was actually being consumed. That's exactly why FinOps emerged, bringing financial accountability to cloud usage by getting finance, engineering, and product teams working from the same picture of consumption. And now, you guessed it, AI is entering that same phase. The FinOps Foundation's State of FinOps 2026 report found that 98% of organizations now manage AI spend, up from 63% in 2025 and 31% in 2024. This is the fastest adoption curve the foundation has ever recorded. But AI isn't exactly cloud, and that difference matters. Cloud costs are tied to infrastructure, where AI costs are tied to behavior. What people ask, what agents do, what models get selected. A cloud dashboard can show that compute spend went up after the fact. An AI control system should actively steer requests to the appropriate method, a cache, a deterministic handler, or a premium model only when the work genuinely requires it. AI FinOps can help explain the bill. AI operations should help prevent the wrong bill from being created in the first place. Two terms need precise definition. Showback means here is what your team used, where chargeback means here is what your team pays for. Showback is softer. It gives visibility without moving money, and that's exactly why it tends to be the better starting point. It changes behavior without immediately turning data into a stick. Think of Uber's surge pricing. The meter runs exactly as designed. Nothing is broken. But a rider who books during a storm can watch the fare land at 5 or 8 times what they expected. Discovered only after the ride is already booked. AI usage runs the same risk. Showback is the usage meter people wish they'd had before the overage bill showed up. Chargeback is not that different from the experience running regulated medical device programs. Partway through a program, a client wants to act on something new the team learned in the process of developing their product. Those changes get tracked separately and billed through a proper change order. Clients are almost always happy to pay. They just need to see the budget. AI now does a growing share of the actual work inside of those out-of-scope changes. But if you can't track where those costs landed, you're either quietly absorbing costs the client would have happily paid or guessing at a number you can't defend. Either way, it comes straight out of margin. The maturity path runs a predictable sequence. One blended invoice nobody can explain. Then usage visibility, showback, chargeback, thresholds, routing optimization, and finally a self-optimizing system. Most companies don't need to start at the last stage. Underneath all of it sits something more important than margin: trust. A client relationship survives on the fact that when costs change, they hear it from you before the invoice lands. AI has not changed that equation. It only made it easier to lose track of the very costs that honesty depends on to maintain your relationship. Let's talk about governance here. Remember when I said in July 2026, IT Pro reported something that seemed almost trivial, where Accenture had instructed some employees to stop using AI for unnecessary tasks because token spend was escalating and the company wanted to preserve resources for higher value work. One specific example that drew attention was converting PDFs into slides. Not medical diagnosis, not autonomous systems, just a routine office task. And that is exactly why the story matters. Accenture's concern was not whether AI could do the task, it was whether the task justified the cost. For a long time, governance conversations focused almost entirely on access. Can employees use ChatGPT? Can developers use coding assistants like Cursor? Those questions matter, but they are only the beginning. The more practical question is when AI is actually the right tool for a given job. And that question cannot be answered by a policy document alone. It requires visibility into usage. A policy that's not connected to observable behavior is not governance. It's guidance. Governance begins the moment an organization can actually see whether its own guidance is being followed. Let's say that again. Governance begins the moment an organization can actually see whether its own guidance is being followed. I organize these thoughts on governance around 3 layers. The first is access governance. Who is allowed to use which tools? Some tools train on user input. Some retain data indefinitely. Neither is appropriate for client data or regulated content by default. But that approved list has to keep changing because new AI tools appear constantly. A governance process that never approves anything new does not stop AI adoption. It just pushes it underground. TechRadar reported that more than half of employees in a UK-focused study were using unapproved AI tools at work. 10% knowingly shared sensitive company data with those tools. The main driver was straightforward. The approved options didn't meet people's actual needs. If the approved path is too narrow, shadow AI becomes the pressure release valve. I worked with a large organization that illustrated this at its most extreme. The company had almost no psychological safety. When AI training arrived, it explicitly prohibited tools that retained interaction history. But every employee had already been given access to Copilot, which keeps exactly that history. So simply using the one tool the company had actually provided put employees in technical violation of their own policy. I also worked with teams around the company looking to improve workflows for their teams or for company employees. And one of the tools we identified would cost roughly $30 a month for a subscription to implement it. Yet nobody would ask their supervisor for approval. It wasn't because the fix wasn't worth it. It's because asking meant becoming visible, and visibility was a risk. That is the part governance dashboards cannot fix alone. The second layer is usage governance, what people are actually doing with AI. And the third is output governance, what review AI-generated work requires before it can be trusted or released. In regulated environments like medtech, an AI-generated draft does not become a controlled record just because it exists. Good governance speeds teams up because the rules are clear and the feedback is immediate. The fix for shadow AI is not more prohibition. It's making the approved environment genuinely useful, combined with feedback simple enough that teams can act without waiting for a committee. Governance starts with usage because usage data tells an organization exactly where governance actually needs to act. That is the real difference between governance by declaration and governance by feedback. The first sounds good in a document, but the second is the only version that actually changes behavior. So how would our lives be made easier if we had a control tower like they have at every airport? Nobody at a busy airport expects every pilot to manage the entire flow of the sky. Pilots know their aircraft, their route, their procedures, but the airport has a completely different problem. Air traffic control exists because individual action becomes system risk the moment many actors share a constrained resource. Someone has to see the whole system. And that's exactly what's happening with AI right now. A developer using a coding agent might be making perfectly reasonable decisions. Product manager adding an AI feature might genuinely be improving the customer experience. And a consultant drafting a report with AI might be accelerating delivery in good faith. Each local decision can make complete sense on its own terms. But the organization still needs to see underneath all of them which tools are being called, which projects are driving the spend, which premium model calls were actually justified, and which were not. None of those are questions any individual user can answer from inside their own task. The dashboard tells you what happened, but a control tower helps you manage what happens next. Most companies start with reporting, and that's the right place to start. A company that cannot see usage can't manage it. But reporting alone stays passive. It tells you the bill went up, that a team crossed a threshold. It doesn't tell you what should happen now. Should the workflow be redesigned? Should a request have hit a cache? Should a client be billed for this? Or whether an automation is out of control and should be throttled or stopped? The dashboard observes, but a control tower coordinates. A mature control tower needs several functions working together. Visibility by user, tool, model, project, and department. Attribution tying usage to real business context, thresholds and alerts, cost allocation support, routing that decides where the work should go before the money is spent, savings verification, confirming that efficiency gains didn't quietly degrade outcomes, governed model access, and auto-optimization that notices when a repeated request should become a cache or a workflow should become deterministic. But auto-optimization was never meant to make architectural decisions unsupervised. Consider a help assistant built over stable, fixed content. Aggressive caching is exactly right there. But consider a support bot reflecting a product that updates weekly. A cached response can quietly hand a user an answer that used to be correct, but isn't any longer. And the fix is not free either. Routing logic layered on top to detect staleness can add several hundred milliseconds to a bot that's supposed to feel instantaneous. Neither approach is wrong. They are correct for different systems. But knowing which one applies requires understanding something about data volatility that an AI resource, left to its own devices, cannot see. The control tower can surface the pattern. Whether it is safe to act on that pattern still belongs to whoever operates the system. The LLM was never meant to be the whole architecture. It's one component inside it. AI adoption tends to move through 5 recognizable levels. One blended bill nobody can explain, then visible usage by tool and project, then usage attributed to real business context, then usage deliberately routed to the right handler, and finally a system that recommends its own improvements. Governance was never a separate stage tacked onto the end. It runs through the entire path. The only real question is whether the control tower gets built before the surprise bill or after. So what's my recommendation? It is that you use AI everywhere that it creates value and build controls everywhere it creates cost. The first phase of AI adoption had a simple question at its center. Can we use this? For most organizations, the answer arrived faster than expected. AI moved from novelty to daily work. It drafted, coded, summarized, and automated. Small teams felt bigger. Slow workflows felt lighter. But then the bill became harder to explain. Not because AI was failing, but because it was succeeding. The more useful it became, the more people used it. The more they used it, the harder it became to know which usage created value, which costs belonged to which client or project, and which automations were quietly running in the background. Uber never taught its riders to stare at a taxi meter. It changed the experience. Request a ride, see the price, trust the machinery. AI needs the same invisibility on the front end and the same rigor on the back end. Use a deterministic handler when one solves the problem, a cache when one answers the question, a smaller model when it produces an accepted result, and a premium model only when genuinely justified. Unmanaged AI tends to collapse into one of 2 bad extremes. Unlimited AI creates hidden costs and hidden risk. Locked down AI creates shadow AI. Control platform is the better path between them. The maturity path is simple to describe, even if the implementation takes real work. First, there is one AI bill. Then usage becomes visible, then attributed, then routed. Then it begins to auto-optimize. The practical advice is equally direct. Start wherever you actually are. Look at the bill. Separate billable client work from non-billable work. Ask which work genuinely requires a premium model. The winners will not be the companies that use the most AI, nor the ones that restrict it most. They will be the ones who can use it boldly and explain it clearly. The meter is already running. The winners will be the ones who know how to read it. So we reached the end of this podcast. I hope you enjoyed this book, The AI Bill Nobody Can Explain, by yours truly, Robert Bouthillier. Available today on Amazon. I wrote this book because I was searching for solutions to the problem described in the book. However, I never found a solution that was aligned with my interests to track usage while reducing costs and reducing climate impact when using AI tools. So I created one. Feel free to check it out with a free 2-week trial at getwrangler.ai. I hope this has been helpful, and I invite you to find more podcasts, episodes, articles, resources, and information about how I help teams work smarter and put AI to practical use at innoguide.net. Until next time, keep learning, keep questioning, and stay curious. I want to thank Steve McIntyre for producing this episode, and I especially want to thank you for joining us. That's a wrap.